Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welcome at the Dutch Kubernetes Podcast, the Kubernetes podcast for everybody. I'm your host, Ronald Kers, and with me, like always, is...
Hello, Ronald. In English.
That went more smoothly than I expected.
Jan Stompers, Solutions Architect, powered by ACC.
Powered by ACC.
Yeah, we're starting in English. New thing, new changes.
Yeah, by request, but we like to cooperate with these kind of things.
So now we switch over to Dutch. Sorry.
No, yeah. Confuse our guest even more, right? Yeah. Luigi Nardi, welcome.
Thank you for having me, guys. I'm excited to be here.
Yeah, nice to have you. And Luigi, can you please introduce yourself to our listeners?
Yes, so I'm Luigi Nardi. I'm the founder and CEO of DBTune. I have mixed background in academia and industry. I was a software engineer for a few years, but I did a big chunk of my career as an academic. Did a PhD in computer science, then a couple of postdocs, one at Imperial College London and one at Stanford University. And then became a professor in artificial intelligence at Lund University, one of the big universities in Sweden. And a few years ago, I left academia and started DBTune, which is hopefully something we'll talk a little bit more about today.
We sure will. But before we get to that, can you tell us a little bit more of your background? How did you get started in the IT? What piqued your interest?
Oh my. So this goes all the way back to my family. My father was an engineer and my older brother was already doing some little coding when I don't even remember when I was like 3 or something. He was 4 years older than me and he was starting very early to do a little bit of coding on Commodore 64.
Nice.
So I don't really remember when I had the first time the computer in front of me. But at that time, I was mainly doing, load and return, which is all you needed to do to load games, video games. So when I was 6 or 7, that was the only thing that I would write pretty much on a computer until I was 14. And then in high school, I decided to pick a school that already had computer science in the classes. So at 14, I started doing my first programming, first on paper, and then was Pascal back then, and then became C a little later, a few years later. And then when I was ready to go to college, I decided to pick a computer engineering university in Italy. I'm originally from Italy and never looked back. And this was really fun.
What is the best feature of Turbo Pascal?
Oh my! That's the prehistory of things for me. So I will not be able to answer the question because I forgot everything about Pascal. Oh, yeah. So if you go to C, maybe I can try to answer some of that. Yeah. I mean, people look at C as a very high-performing, language, and I think if you know how to write C, though, because if you write it wrongly, there are some things that cannot be inferred automatically at the compiler level, right? So if you know how to write C code in a performant way, it can be really, really performant, and in fact, that's the reason why it's behind some of the big open source, like Postgres, for example, which is written in C, and so on. There was another language back then, I would talk about like maybe 20, 25 years ago, that was considered a little better for performance because you didn't need to be very well aware of the way you write vectors, for example. You didn't need to add any additional syntax to show that this can be parallelized, for example, so the compiler can generate parallel code and this was Fortran.
Oh, yeah. Fortran.
Okay, let's pause for a second there.
I'm not asking things about Fortran. And then you rolled in databases.
Yeah, so databases is something I studied in college, so it was always kind of part of the environment somehow. But I didn't focus on databases until a little later. I continued with did research on machine learning technology, models, training models, and creating new models as well, creating new methods to optimize things using machine learning, for example. probabilistic models and Bayesian methods, things like that. So I did work a lot on that part and applying that technology to the optimization of computer systems. So for me, it was really fascinating to combine what you can do with applied mathematics, if you wish, and the aspect of you have a computer system, how do you improve the quality of that computer system? I'm using computer systems as a kind of general term here because you have computer systems of all sorts of different types. Right?
Yeah.
You have computer vision systems, you have compiler systems, you have robots, you have databases, and you have all sorts of other things, Kubernetes and so on. So all those things can be improved through automation. And for me, automation that is written through rules, if this, do that, has a strong limitation. And so I wanted to do something that learns from the current kind of usage of the technology. And so that's why machine learning and AI is what really is interesting for me, because you can learn from the specific use instead of writing a number of rules and then following them like that, right? So yes, I worked a lot on that, and then eventually a little later, started working much more heavily on databases, especially applying machine learning technology to improve the quality of database systems.
Okay, so DBTune. What can you explain to me about DBTune? What do I need to know about DBTune? What does it do? Because I am not familiar with it, but you're sitting here now, so tell me, what is DBTune?
Right. So this is really the idea that if you take a open source database, that comes shipped as a generic package. And if you want to take that and run it in the best way for your environment and your use case, you will need to do this thing that we call tuning. Okay. And tuning, usually performance tuning, right? So performance tuning means that you will change the generic package and make it specific to your use case so that you achieve higher performance. And so this is a problem that was basically born at the same time as databases were born, right? So it always been there, right? So if you have a piece of database, you will also need to tune it based on the machine that you have and the workload that you have to make it do what you want.
For the performance, right?
For the performance.
And if you talk about tuning, what basic things are we talking about then?
Right. So in a database system, you can tune a bunch of different things. You can tune the runtime system of the server. Think about the von Neumann machine, right? So you have the disk, you have the memory, you have the CPUs. And what you're doing with databases is to move data from the disk to the registers of the CPU, going through the memory. And all this data flow needs to be really smooth, because if you spill to disk, there is an order of magnitude performance left on the table. So if you can keep things locally, both temporally and locality in all shapes or form, then you will allow the data not to spill to disk, and then you gain a lot of performance juice. So this is one of the aspects that you can tune in a database. There are other things, like, for example, indices. You can improve the quality of the indices or drop some indices. You can also rewrite the statements, the SQL statements, and that is more like application layer type of optimization. And you can even go all the way down to the operating system, right? You can change things in the operating system itself, which is also highly configurable, by the way. So if you really want to squeeze performance, you could also act at that layer, which is, the foundation layer for the database on top, right?
Okay.
So DBTune focuses on one of these things for now, but we are expanding into other areas as well. We focus mainly on the server parameter tuning side of things.
Yeah, because when I've looked from experience of people I knew that were working with databases, okay, mostly MySQL, not the MySQL, MS SQL. Sorry, Jan. They always felt like wizardry, what they could do with the databases, because you need to have a specific skill set to manage and tune the databases. How does AI solve that problem?
Right. So these are usually problems that are pretty complex in nature. They are dependent on the combination of the SKU and the workload. So you cannot pre-cook a formula that just works everywhere. So all the methods that will do that, they will fail because it's a fundamentally kind of wrong way of doing this, right? So you need to be able to look at the workload that is running, the machine that is running on. And this is a spectrum of different workloads. There is just not just like two types of workload, read heavy, write heavy. That's not how it works. You have a spectrum of different workloads. And so the tuning needs to really reflect the workload itself based also on the machine that is running on. And so AI is, not trying to be fancy with the word AI here. It's just that is the technology that allows you to learn by observation. And it can have this loop where you observe, learn something, and then act on the environment. And then you loop again, right? So then you observe again, learn something new, and then loop again and back to changing the environment, actioning on what you've learned. And so this is fundamentally what AI does. And so you can improve the system using this automated learning and then automated action taking, right? And decision making on what the actions should be. So maybe the last thing I will add is that these problems are usually combinatorial optimization problems, and human beings are really, really good at many, many things, but not at combinatorial optimization problems. Because by nature, you need to basically be able to explore multiple dimensions at the same time. And it's usually one dimension depends on the other one. So if you change one thing, you need to take care of the other ones all at the same time. So it's a joint optimization across this optimization space that can be quite challenging. And that's just what AI is really good at. And so, so that's what you can do with that type of approach.
Okay. And DeepTune, is it for any kind of database? MySQL, MS SQL, Postgres, MongoDB, is that all like the same approach, or?
So we have proven the concept on a number of different database management systems, both relational and NoSQL, including Postgres, MySQL, SAP HANA on the relational database side, and Foundation DB and RocksDB on the NoSQL side. That being said, we decided to focus on one of them for now in terms of like creating an offering that we are actively distributing for a couple of years now, and just focusing our go-to-market effort on that one technology, and that one is Postgres. So we're really focusing on Postgres. So we are a Postgres company and an AI company at the same time. For now, this is all we do.
Okay, so you're focusing on making indices or more on the system side? So what are you tuning? Memory of the database and connections, all system values?
Right. So there are these parameters in Postgres that are called GUCs sometimes. If you're deep in the Postgres culture, you'll probably hear this GUC. So that's, for example, things like if you have one query that is running, you need to allocate a bunch of RAM. You have this much RAM, you will allocate a little bit of this RAM for that query.
Yeah.
Okay. And you will have a parameter that decides how big is this buffer, right? And what that buffer does for you is that if you run this query now and you have this much buffer, you can do sorting operations using this very local memory. It's dedicated for that query, so you can use it without disruption, right? And if that buffer for a given query is big enough, then what happens is that you keep all the data locally and you don't spill to disk, which means that you can really achieve very much more performance by keeping the data locally like that. So this is just one example for memory. Of course, there are multiple memory parameters, but there are also, other than this one, but there are also parameters that concern parallelism, for example. So things like, again, if you're running a query, Postgres needs to decide how many workers can work on that query in parallel. So if you're doing a sequential scan, for example, you may do, parallelism there.
It is something like on an Oracle plan. Can I make a similarity there? Because if you do an Oracle learns also from your workload, and you can plan your queries and have a path, the same path always to run that query, so it's optimized. So optimizing your queries.
I think when you talk about the Oracle plan, you're probably referring to the Postgres planner, query planner. And the query planner is actually influenced by these parameters that you set up in terms of memory disk, the wall, the BG rider, the background rider, and parallelism. So these parameters influence the planner and the way the planner will execute the queries, right? So perhaps there is a parallel there. The interesting thing about the planner is that when things change, the planner can change. In Postgres, sometimes the planner will change without, telling you, right? So that means that the planner is smart enough to decide that there is a better way to execute the queries now. And so the trigger for the planner to change could be things like the statistics of the table. So table went from 999 lines, rows to 1,000. That's the trigger, right? And now the planner is doing something different, which also means that your performance for those queries has changed, right? Because they will be executed in a different way. Think about, like, for example, sequential scan versus an index scan, for example, and that will flip that switch and things can change quite dramatically, right? And so these parameters really affect the way the planner works. And the planner is sometimes also not perfect. And the interesting thing is that with this type of automation, you can kind of patch in a soft way the planner by finding the parameters that provide the best performance, right? So it's interesting that you can also use this automation to actually kind of make this soft patches to the planner, basically, in a way that the queries get faster. Yeah.
Why is that not in standardly then in Postgres then? Just
why it's not in Postgres? You mean in the source code? Yeah, I think it should, and perhaps it will. There are other projects that do this kind of adjustments on the server parameters. I would like to cite maybe one of them called pgtune. pgtune is an open source project that, very simplistic web page where you input your RAM and CPU and disk type, and you push a button and generates a configuration file that you can just copy paste in your pgconf and you're done. But the problem is that it really doesn't look at your workload, so there's a limited approach there. So it doesn't do the full thing. So it gives you like a first guess, but it doesn't do the rest, which is looking at the workload and adjusting with respect to the.
Are you adjusting real time or near real time? So if you see a query and that query comes the second time, are you adjusting then?
Yeah, so Jan, that's I think the fascinating part of this whole thing, because ideally this type of tuning exercise needs to happen on your real system, right?
Yeah.
Not on a copy, not on a digital twin.
No, that's not the word.
Yeah, so we engineered dbtune in a way that it can run in your production system, and the reason why it's absolutely safe to use in a production system is that we don't use LLMs, because we cannot allow the machine learning models to hallucinate, right? So we engineered a different type of machine learning models that are much more robust in terms of the predictions and also the confidence intervals that they have around those predictions. And then we injected a lot of Postgres specific knowledge to constrain what the agent can do. And the agent is absolutely narrow in scope. It will not answer questions about the weather or politics or, in the same way ChatGPT or Gemini will do, right? What it will do is one task, and it's about Postgres performance tuning. And by narrowing the scope all the way down to this very specific task, you can make it safe to run in a production system, right? We were working with a company the other day. They mentioned they are doing some, water management for a large region. And one of the things that they said is that if the agent jeopardizes my system, this hospital over here may not get water tomorrow. Mm-hmm. And we were absolutely comfortable and fine with that because we know that we will not jeopardize the system, right? And in fact, this was a tuning session that lasted just a few hours and improved the performance by 2.5x on the production system. So you plug the agent in and you wait a few hours, you don't change one line of code, and the system becomes 2.5 times faster on RDS.
But if you keep it plugged in, how fast is he changing then?
It's making a few changes iteratively. So it iterates. I don't know if you have ever studied like optimization in school. There are these algorithms that kind of converge into this optimal solution, and that's what it's doing. So it converges into something that is
slowly
optimal. Slowly changing a few times the system in just a few hours, and then usually after 3 hours you get your solution. After that, we engineer the system. We design the system in a way that doesn't keep changing things when you're not looking. We want to keep you comfortable with the fact that
because your system can change. You said if the table becomes bigger than 999 and 1000, you probably need the indices or something else because the table is getting too big, and then you will get a slowdown again. So
then you will trigger it again, and it's just push a button, or you can do it in
hardware can also change, right?
Yeah.
You can also get more memory or an extra CPU. That's also change that can happen.
And that's exactly why this type of solutions are more needed now in the cloud era, where things are changing much more than before. Imagine if you have a legacy system running in a basement where fixed hardware, the application doesn't get developed very much. There's no new feature development happening. Everything is kind of fixed.
Still, things can change.
Yeah, but that's interesting because let's say we scale up like horizontally, right? No,
vertically, yeah.
right?
The database is horizontally.
No, true. Yeah, I corrected myself.
Autocorrect.
So yeah, optimizing.
Oh yeah, DB tuning.
Yeah. I'm DB tuning myself. You see it will live work. No, but after a while, it will scale down. So it needs to optimize again for the lower resources again. So I think there's a playing field there, right?
Yes, I think there is some sort of misconception in the industry that you tune things once and then you forget about it. I think this framework of tuning once and being good for the next 2 years or something is something that relates to the past. Well, you really have something really doesn't change very much, and you don't make a lot of major upgrade of the database system as well, and so on. But there are a number of triggering points where you may want to tune again. What you just described is one of them. In the cloud, you get quite regularly this going up and down type of scenario with seasonal workloads and things like that. And so when you go up, you're technically changing the hardware. And if you change the hardware, you changed one of the two things that will require tuning, right? The workload as well. If you change the workload itself, meaning that you're shipping new features, or the workload mixture is changing somehow because there is a different usage.
Doing something.
But does this work on an AWS RDS service?
Yeah, so we support a number of different Postgres flavors, the way I call them. I mean, it's the same Postgres, but running on different type of cloud providers and so on, but also self-hosted. So we support AWS RDS, AWS Aurora, Flexible Server, Azure Flexible Server, Google Cloud SQL. We also are here at KubeCon today because we support Cloud Native PG, which is the Postgres operator for Kubernetes. So a number of different other Postgres flavors. But basically, you can cover most of them because there is an API. Usually, the cloud providers provide an API that you can use to access the data that you need for tuning, which is mainly the performance data. You don't need to really look inside the tables. You just need the performance data that the agent needs to be able to read, and you can do that through API access. But you also need to be able to change the configuration of the server. And to change the configuration of the server, there is another API that usually allows you to do that. So if the cloud provider is flexible enough, we can do everything we need. And the big cloud providers are all flexible in that sense, because if you're not tuning with dbTune, you may want to tune with something else. So you still need to have that flexibility, even if you're not doing it with an AI agent, right?
So from a practicality standpoint, I spin up like a database like Postgres. And is it simply just adding the agent with dbTune to connect to the database, or how does that work? How does does it route the traffic through the agent and then back to the database?
Yeah, so
container.
So dbTune acts at the Postgres instance level.
Okay.
So it doesn't have to have any relationship with the application, right? And the agent, it's this middleman between the database instance and our optimization engine. So the agent is a very lightweight open source piece of code that can run in many different ways. But usually you install it if you're doing RDS, for example, you can install it literally everywhere. You can install it even on your laptop if you want. But I don't recommend that you do that for a production system, right? But otherwise, you will put it in a cluster or in a Kubernetes cluster, or you put it in a virtual machine, for example, or in a Fargate.
So it runs separately then.
Yeah, okay. That's for my
For you.
image in my head how it would look.
So it's not installed on the database server. It
Well,
runs
you
separately.
can, on RDS you can't.
No, of course not.
Yeah, so that's why. But if you're self-hosting your Postgres, then you can install it as
Yeah,
a
of course,
little
but
container close to the database, and that would be.
it looks at the process. It can optimize.
It looks.
Yeah, no. I'm just
But is it reading WAL files or just only logging?
It's accessing the database metrics through an extension called pgstat statements. And it's looking at some additional kind of performance-related things like CPU usage and things like that. But so all those things can, again, if there is the self-hosted Postgres versus the fully managed with the cloud providers. So in both cases, you can access those things, even if you're using a provided Postgres service, because there is an API for those kind of things. So it's just a matter of like creating this API access through the agent. And so any new cloud provider, you just need to basically add this additional adapter in the agent that access the API to get this basic performance data. Yeah.
everything okay?
Yeah.
Makes sense.
One day sneezing a bit. Doesn't matter. Yeah, do we need, if we use dbtune, do we need that DBA still?
DBAs are needed.
Cool.
We're not. They're absolutely needed. They're absolutely important, even if it's I'll say a role and a profession that is slowly disappearing. Unfortunately, I would say, because platform engineers are taking over, but we're not
Taking over the world.
I don't think dbtune is really automating the work of a DBA. I think it should be taught as an assistant that the DBA can use to be more productive. And now there is this one task that can be automated. So DBAs should focus on the other very critical tasks that are part of the database administrator job.
dbtune does not everything, only the database. So you still have your CPU, memory, and the other things if you're self-hosted, of course. So that's the DB. We'll cut that out.
No, but we will edit it. Oh, right. There's a photo. You want to? He's all white now. So
Good.
repeat the last question.
I forgot the last question. So, the DBAs, what kind of work do they have to do then? Because the DBAs I know do database things in the database, and they could change the memory and CPUs of the database, but that's a platform engineer's work. So
Yeah. I mean, if you think about, again, I think we need to kind of distinguish, so to separate the self-hosted Postgres versus the managed Postgres. But in general, database administrators do things like, think about backups and thinking about point-in-time recovery, thinking about high availability, thinking about the architecture itself of the database system as well. How do we want to run this? How many replicas? All these kind of things, right? And then, of course, if there is some sort of issue, those are the first people that will come and fix the issue, right? So the level of automation around Postgres is increasing over time. If you think about the fully managed offers, called fully managed, even if they're partially managed, in my opinion. But whatever, that's a debate for another time. But if you look at RDS or Flexible Server on Azure, so those are really interesting because they automate some of these other things, right? Backups and high availability and so on. So if you're using those kind of things, you don't need to think about that anymore, right? Yeah, this is just happening in the background. But there are still, all sorts of other things that the database administrator will do. So if you have a problem on your database, these cloud providers that will not fix it for you. It's just really still up to you to figure out what's going on and go solve the problem, right? So I think it would be really naive to think that
Is it the same like if do we need software engineers anymore because we have AI? It's the same kind of question, right? For optimizing or stuff. There are tools that extend of help the professionals or the DBA and database administrators, but still there are kind of wizards if you know what you're looking at in a database. I can remember from the past when you look at there was a problem in the database itself that needed to be fixed. There's no optimization tool that's going to fix that for you if the database itself is broken.
The Microsoft optimization tool. Yeah, that worked.
I didn't say that.
Sorry. Yeah, probably.
So I think it's this idea of AI-assisted engineering, which is kind of taking over the industry of software in general.
That's how it is.
The idea that there is an assistant now that can help you to do quite a few things even. But yeah, I mean, people are still in charge in a big way. You cannot just ship things,
Not yet.
Yeah, not yet. Yeah, in the future, I'm pretty open to what's going to happen in the future. But if we talk about right now, this is kind of the reality. You can accelerate yourself by a large margin, but you're still kind of in charge, right?
What is your biggest challenge in DBTune?
So we've seen a user psychology shift that was really, really interesting in the industry, right? So when we started talking about agentic AI, we didn't talk about this precise way of saying it. We had an AI agent. So before Sam Altman gave it the name, or whoever gave it that name, in 2023, I think this was starting, right, with ChatGPT release and so on. I think it was roughly at that timeline. So before that, we were already in business, and it was, I think, a little more challenging to talk about these things, especially with very large conservative industries. But today, this idea is just there. So when we talk about this topic, it doesn't really get any. The response is not a scary face, if you say. So this is much more accepted today, and it's much easier to make this technology adopted by even conservative industries, right? And so we saw really this change in the last 3 years. So we saw that people have changed their reaction to having an agent that runs in your production system and does things for you autonomously, not just giving you a little recommendation, but actually doing it for you, right? So removing the cognitive load from you and being able to trust something that has been engineered in a very narrow, specific way for that specific task. So this was really, really interesting, I think. In some sense, all the top leaders in Silicon Valley talking about, agents that do things in the real world. This is something that we were already saying back then, but it helps that they are saying it out loud now, because the people listen to them more than they listen to me or us, right? So, and so in that sense, it really helped us, because it's much easier now to get this widely accepted. And yeah, and everybody's looking for adopting AI in some shape or form, right? So and of course, text processing is the first thing, and it's used very widely used today. But people are thinking, how do we move from that to something even more, meaningful? And infrastructure-related AI things are certainly a hot topic right now. And so people are really looking for ways, especially coming also from the C-level executives and so on, that they want to have more adoption of this type of automation. So this certainly helps us, and it goes in our direction.
Cool. What is the biggest thing that went wrong? Do you have a story about that went wrong in DB2? Or
It optimized maybe a little bit too much.
So I like this format because you guys don't give questions in advance, so it's all very natural. I love this. So I wasn't expecting this question, but one thing that of course the product has evolved a lot in the last few years, right? And at the beginning, the optimizer was giving, it was going through this recommendation, but also applying the recommendation and moving into this feedback loop until convergence, right? But the values of the parameters were a little oscillating a little too much. And you don't want that in a production system. You don't want me to change the working memory by this much and then say, oh, no, let's go back to something very different, because I need to kind of see what's going on if I do that. So that was, a couple of years ago, we had this kind of, and a couple of users have noticed that, and they were uncomfortable running this in production with this kind of oscillating values. And so we came up with a new model that we call Newton. We call it Newton because we wanted it to have this sense of gravity. So the idea that these parameters need to kind of fall back into a predefined default that the users are comfortable with, and they don't need to diverge too much from this value. And so this is the concept of gravity as well, like the apple that falls on the floor and stays on the floor unless you take it and you put energy to bring it up, right? So if there is an energy in the system that brings that apple away from the floor, in that sense of the memory away from this default value, then it's okay because you gain performance. Otherwise, we don't want that to move around in a kind of hectic manner. And so this created some friction with a few people, and say it raised some eyebrows. Someone wrote a blog post, and it was, there was this paragraph that was not very happy about that part. And so it's a bit of a shame because when these blog posts get written as well, they kind of stay there forever. And but it's a small thing. But we fixed that with this kind of smart way of engineering the model, and we didn't see that issue anymore. And that's cool.
Oh, awesome!
Yeah, cool. Yeah. I think it's time for the final question.
Yeah, time for the final question.
Oh my, I'm shaking.
Don't worry. Our question is always, how do you foresee the future of Kubernetes? So, if I would like to see. So, if I will use the analogy again. It's been a long time since I used a crystal ball. If we would put a crystal ball on the table, how would you like to see? What would you like to see in it for the future of Kubernetes and with DB2?
Right. So for me, the declarative way of Kubernetes is something really, really appealing. And I think what, declarative versus imperative, right? So the way of declaring things and just defining the task instead of defining the steps to do it. That's, I think, very, very appealing. And I think for what concerns us at DB2, for the performance part, we are seeing that part is completely lacking, right? And so that's why we are excited about the cloud native PG integration that we did, because that adds this additional, dimension to Kubernetes and Postgres in a way that you can now declare that you want a performance management automated, right? And then it just happens behind the scenes. So this is, I think, a pretty big improvement for Kubernetes because Kubernetes/Postgres, right? Because Cloud Native PG, the operator, is being adopted very, very widely right now. It's an extremely successful project. We were at KubeCon in the last couple of days. Literally, I think 80-90% of people knew about Cloud Native PG, right? You will talk about Cloud Native PG, people will just know what that is and what it does, and many of them were just using it already. And so the aspect of performance, now that this is becoming so widespread, is extremely important because this gets now deployed. There is a talk tomorrow about HSBC using CNPG, for example. It's a very large bank. There was another talk recently on Tesla and CNPG. So these are very large deployments running in Kubernetes Postgres, right? It's CNPG. And I think when you go at that scale, performance becomes extremely crucial to push this project even further, right? So we're talking about many terabytes of data for one instance, right? And at that scale, performance becomes extremely important. There is a second aspect that I think is also really interesting, which is you can do tuning not just because you need better performance, but you may also decide to do tuning because you want to use a smaller instance. So this is the idea that you start from this level of performance right here, and you increase the performance this much with tuning. But if the objective wasn't really to improve the performance, now you have this much headroom to shrink the instance down and use a smaller instance, which basically has the effect of optimizing your infrastructure cost. And that's absolutely crucial, especially like 2025 already, but 2026 seems that everybody is talking about financial DevOps, FinOps in short. And so tuning and performance tuning can be seen both from a performance specific way, but also can be seen in a FinOps way, right? So we're trying to optimize the performance with the objective of shrinking down your instance. And I think that's exciting for Postgres and Kubernetes, especially because Kubernetes allows this resizing pretty easily. And so those things seem to go very, very well together.
Yeah, and is there also like a that is okay? It was not the final question, but this was.
So your crystal ball is broken.
No, we talked a lot about Postgres. Is there also another database you're looking at already for optimization?
We have done some proof of concepts, but we're not planning to go in that direction in the very short term. Okay. So we're really focusing on Postgres. We're very excited about Postgres and the way Postgres is really dominating the relational database.
I can imagine people hearing this that I want this, but I just don't run Postgres yet. I have this, and maybe there's something there, but maybe in the future I'll just switch to Postgres.
Yeah, switching to Postgres, I think it may be a good idea.
For NoSQL databases, switching to Postgres is not an option. He can do it.
Why?
No.
Luigi, thank you very much.
Thank you guys. That was so much fun.
Okay.
I'm thinking more. Thank you very much.